Let's take a look at angles inside of a triangle. Well, the first thing that we have to do is we're going to take a look at a few triangles. And now we're going to kind of prove something that we somewhat already know, but let's go through and let's just make sure we understand our angles properly here. So a triangle is made up of 3 sides and 3 vertices, or what we might call an angle. 3 types of triangles may be used. The first one is what we call an equilateral triangle, where each side and angle is equal. And so that means that this angle, and this angle all have to be exactly the same. Now, we know from previously known fact that all 3 angles have to add up to 180, so we know that in an equilateral triangle, they are all exactly 60 degrees. And that's something that we can kind of show in an equilateral triangle, and we're going to go and prove that in just a little bit as well. An isosceles triangle is a little bit different. In this case here, it's where 2 sides and 2 angles are equal, but we don't know the exact measurements. This angle and this angle are going to be equal as well, and then the third angle is a bit different. Now, based on what we've done in trigonometry a little while back, we know that this side is corresponding to this side, and this side is corresponding to this side. So these 2 sides are equal, these 2 angles have to be equal as well. Now again, we don't know what they are, but we know that they're going to be equal. So if we're given this third angle, we could find what these ones are, or if we know what one of them is, well, we know the other one is exactly the same. The final type of triangle right here is a scalene triangle. No sides or angles are equal. So we have 3 different ones. We have, we'll call it theta, and we've done this now a little bit in the past, alpha, and that's beta. We have 3 different angles, 3 different sides, and we can find all 3 of them kind of as we go. Now, in a triangle, the sum of the angles is equal to 180 degrees. And we're going to go through a short little proof as to how this works. Okay, so we're going to go through a short little proof as to how this works. And so we have here triangles made up of 3 angles, these 3 right here, and we're going to say that this line right here is parallel to this line right here. And so we need to do that in our proof. So this line and this line are going to be parallel. Okay, so based on that, we know that, and I'm going to put our kind of our proof down here. We know that G plus H plus I is equal to 180 degrees, and we know that this is based on supplementary angles. We know that G has to equal J, okay, and this is based on this is interior, IAAC. Interior angles are always going to be congruent. Okay, so we have, sorry, this is alternate interior. There we go. Made my first little mistake on here. Sorry. So interior alternate angles. It's right. Yeah, it's interior alternate angles are congruent. So G and J have to be the same, and by the same policy or by the same proof, we know that I and K have to be the same. So I is equal to K by the exact same proof right there. Okay, so based on this here, we know that G equals J. And try saying that a few times fast. Yeah, thankfully I don't have to say it once, or maybe twice now. G equals J, so we can replace it there. So we're going to say that is J is equal or plus H, and I is equal to K, so we're going to replace that there. So we put K has to equal to 180 degrees. So that means that J, H, and K, so triangle triangle X, Y, Z, okay, has angles, and let's move that up just a little bit, which add to 180 degrees. Okay, so that is how we can prove it. Just a short little proof on supplementary and interior alternate angles are congruent. And again, if these 2 lines are not parallel, then it's all out the window. We can't actually use that. But because we made them parallel, that's how we can prove that this in fact works.